Hey everybody, this is Larry. This is me on May 12th. That date feels a little familiar. Have I done this a lot? I don't know. Let's do an RNG problem. Yeah, hit the like button, the subscribe button, join me on Discord. Let me know what you think about this one. And today we have 1111 maximum nesting depth of 2 radded parentheses strings. And of course, it has 1700 downvotes. The ratio is terrible, but we'll see. We'll take a look. What do we want to say? Okay, so there's a radded string. It's just defining what a radded parentheses string is. Okay, and nested depth is just, okay, we should know what depths are, right? It's been a 2 disjoint subsequence AB such that A and B's are now, okay. Say what? Say what? I was following up until now. Oh, okay. Such that, okay. So then that means that these are part of, so such that A and B, okay, yeah, but what where max, okay. Okay. I mean, I think the most naive thing that I would have wanted to do is dynamic programming, to be honest. And dynamic programming, you could do something on the size of n, maybe sequence A and sequence B. But of course, that is going to be n cubed, which for this appears to be too slow. Right? So then now, I'm just thinking. I mean, I think. Yeah, I mean, it's tricky for sure. I think my idea immediately is just binary search on one answer. On A. I wonder if you can prove that. So okay, so because I feel like let's say there's a max depth of the entire sequence, right? You probably can only take away half of it. So the solution is going to be, where max. So if you binary search on a number, then either. Okay, I see. Okay, there's another way of phrasing it, I suppose, which is that, okay, right? And I don't know if this is good. We'll see if it's true. But let's say you binary search on the depth of A and then just greedy to figure out if it's possible, right? Is that? Yeah. And basically the idea then now, because you're trying to minimize max of this, another way of phrasing this is just minimizing depth of A minus depth of B, the absolute value of, right? Which is another way of saying we want to get this as close to 0 as possible, right? We want to get this to as close to 0 as possible, and we can, we could find the first depth of A such that this thing is less than 0 or something like this, right? So we can maybe binary search on it. Yeah. The other thing is, and I don't know if this is true. I mean, binary search is definitely a possibility. But the other thing that I'm thinking of is that, okay, let's say we calculate the depth of just a sequence. Is it always going to be just half of it is A, half of it is B? Like if the max depth is 9, random number, does it mean that 4 and 5 is always possible? I think probably, to be honest. I don't have a proof, but because it's subsequence, we can always break it up into 2 different, like if you have a stack size of 9, you always break into a stack of 4 and 5, right? In theory. I think that's where I'm leaning toward. We can go back to the binaries, and yeah, we can go back to binary search, but this is my idea for now. So then, okay. So then max step is equal to 0, current is equal to 0, and then now for C and SQL, if C is equal to oops. Max step is equal to max current. And we assume that this is routed, right? Because, yeah, I think they mentioned it, but I could be wrong. So then I don't have to check for this being 0, right? Okay, so then now we have max depth. So then now we can say A depth is equal to max depth divided by 2, right? And of course, B depth is just the other thing, but we don't even have to care about it. And then now we just do it again in a greedy kind of way. Which is what I would have done with the binary search anyway. So yeah, which is then now if C is equal to right, then now we do some magic, which is that we have to set current is equal to 0 again, right? And we have to do, I guess, answer is equal to none times n. I like to make it none and not use one value so that it makes debugging easier. But yeah, okay. So then now if current plus 1 is less than or equal to A depth, A max depth, I guess, then we put it as A, right? So index is equal to 0 and current we increment by 1, right? Else, that means that we have too much on the A depth, then we set it to 1. And we don't even care about the B side because we just assume it'll be routed, right? Else, if current minus 1 is greater than or equal to 0, then answer of index is equal to 0. Current subtract by 1, else. Anyway, yeah, I don't know if this is good, to be honest. We'll give it a spin. It looks good for here. Let's give it a submit. And there we go. No proof, no notes. I think it's just, part of it is, I think if this problem was a sub-array, then it's a very different problem. But because it's subsequence, I mean, and this is my visualization in my head, which I don't have a strong proof on. But let's say you have something like this, right? And there may be stuff in the middle that complicate things, like maybe here there's another thingy, but then you could just remove it, right? So for all purposes, they should be the same. And here, you can always choose alternating one as A and B. And as a result, that's why you're able to get this half thing, right? Because when you kind of remove all the extra stuff that does not affect the max step, which is the only thing you care about, it's always going to be some variation of this, right? Because you can have extra thingies, but then you just delete them and not, they don't exist. They cancel each other out or whatever, right? But yeah, that's basically the idea. And obviously this is linear time, linear space. Can't do better than that. You have to look at every input, so that's just linear time. And of course linear spaces, because that's the size of the output. We don't even actually do anything other than the size of the output. So that's lower bound anyway. Yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.